Okay, I'm just going to go through some instructions for if you're a student who didn't do the prac. So students who are on camp or new students. What you're going to have to do for this prac is you're going to write out some reactions between the different solutions. You don't have any results to go on, but you can obviously just use the chemicals. This is the list of them, and I'll put a photo of that up, or I'll list them up on the dash page. You just pick two random ones and you'll write out a chemical equation to show the reaction between those two chemicals. And then you'll use the solubility rules, which are in your prac sheet, those ones, to work out whether a precipitate would form and which chemical would form it. So I'm going to do an example of what you would do, and I'm going to just pretend that I've picked potassium iodide and lead nitrate. So the first thing that I would suggest you do is to write out the word chemical equation. So I'm going to do it super small. Potassium iodide plus lead nitrate makes, and you basically are going to switch the front with the back and the front with the back. So it'll be potassium nitrate, remember they are switching their dancing partners, plus lead, it's hard to film and write, lead iodide. So you can see, maybe I'll go sideways, that's going to not work, is it? Alright, so potassium iodide plus lead nitrate makes potassium nitrate plus lead iodide. So you can see I have to switch their partners, always writing the metal first, which is the positive ion, and the negative ion second. So I would never write nitrate potassium, so it's potassium nitrate. Then I can use the formulas that I have over here next to my table for the solutions that I used. So potassium iodide I know is, I'm going to really condense this down, potassium iodide plus lead nitrate, that's a 2, makes, now this is where you don't know the formulas. So what you do is you just write out the components and then you work out whether you need 2 or 3 of those components. So potassium is K and nitrate is NO3. Remember I said if you're a bit worried about these molecule lines, you can just do them in brackets just for safety, so that if you do end up putting a number there, you'll make sure the number applies to the whole molecule ion. Then lead iodide, so Pb for lead and I for iodide. Now I would check my valency table and I'd find that potassium is a 1+ and nitrate is a 1-. So I know that 1+, 1-, it's a bit like having K+ and nitrate 1-, makes the perfect puzzle. So that chemical formula is correct. Then over here I have lead iodide. Lead is 2+ and iodide is 1-. So I know that my puzzle will have 2 positive prongs. That's for the lead. And if I only use 1 iodide atom, then I'm going to have a missing puzzle piece. So I need 2 to create a neutral setting, 2 pluses, 2 minuses. To just show that I have 2 iodides, I put a little 2 there. Right, and I'd get rid of this. This is just my working. So now I've written out my chemical equation for my precipitate reaction. I've got all my chemical formulas correct, so I don't need to worry about those now. And now I'm going to balance. Now, I've already done a video on balancing, so I'm going to not do the full big T, draw it all out balancing. I'm just going to do a quick version, which is where I just do a little tick. So K, I've got 1 potassium, 1 potassium. Normally I don't like collectively considering nitrate when I'm balancing, but I know what I'm doing, so I'm going to. I've got 1 nitrate here, but I've got 2 over here. So to balance that one, I need to put a 2 out the front here That'll fix up my nitrates, but my potassium is now 2. So I need to put a big 2 there to fix that potassium up. I've got 2 iodides here. I've got 2 there, 1 lead, 1 lead. So potassium's 2 and 2, iodide's 2 and 2, lead's 1 and 1, nitrates as a whole, I've got 2, nitrates as a whole, I've got 2. So we're all balanced now. Get rid of those ticks. Okay, so my equation is now balanced. Now I need to work through my solubility rules to find whether I would get a precipitate. Now, although we've been talking about the fact that the 2 reactants that we use should have been soluble, we've just discovered in my first demonstration that they weren't all that way. In fact, some of the solutions we were using were already cloudy and had evidence of a solid in them before we'd actually mixed them. So they were throwing a few odd results because it's hard to tell whether we got a new precipitate or whether it was just the existing one. So let's do a bit of a check of our solubility rules. So all compounds containing sodium, ammonium, potassium or nitrate ions will dissolve in water. Compounds containing these ions never form precipitates. So we know that sodium, we don't have that, ammonium, potassium. So any of our compounds here that contain potassium will never form a solid or a precipitate. So potassium iodide won't, and neither will potassium nitrate. Anything containing nitrate ions also will never form a precipitate. So lead nitrate, AQ for aqueous solution. We already know that potassium nitrate doesn't because of the presence of the potassium ion, so the nitrate ion doubles that evidence that it will not form a precipitate. We've only got lead iodide left. So let's work through our rules. So the first rule we've already sorted. Second rule, compounds containing chloride, bromide and iodide ions are soluble. So we've got lead iodide, so it's saying it's soluble if it's got iodide, except when they contain silver, lead or mercury ions. So we know that we've got lead in there. So because even though iodide doesn't form precipitates, if it's combined with lead then it does, and so it would indicate that with a S for solid. And that is your precipitate reaction. Ta-da! So you'll just do that process for some other combinations. Now, for those who weren't here, these combinations, I just did that one. This combination, and that combination formed precipitates. This was the one we did in class in my other video, and we know that that is actually insoluble in water. So we were using a solution that was already insoluble. Hence you might have thought it had got a precipitate in it, but it was actually itself showing a precipitate. Alright, hopefully that's helpful. I'll see you in a week.